Can you all hear me?
I can hear you.
Maybe we shall wait for another 2 minutes. Maybe we shall start.
Yes. Oh, okay.
Yes. Okay. A very good afternoon to firstly to our speaker and also our panelists for our event, and to all the attendees present here today. Thank you for taking the time to join us. I see the attendees are not only our computer science students, but attendees outside the UNIMAS. Thank you for joining us. I'm Sze San Nah, a senior lecturer of Faculty of Computer Science and Information Technology, Universiti Malaysia, Sarawak. Ladies and gentlemen, today marks a history of UNIMAS, as this is the first time that the university celebrates the International Day of Mathematics. Who knows the values of pi? Yes, it is 3.14. Therefore, every year of the 14th March, those countries that write the date as 314 celebrate the day as a Pi Day. Only in 2019, the UNESCO has proclaimed 14 March as the International Day of Mathematics. So, the first International Day of Mathematics was launched and celebrated worldwide on the March 14, 2020. Here in UNIMAS, we miss it due to the pandemic. But this year, we do not want to miss out. It is a very simple way to celebrate the event, but I'm sure it is a very meaningful way. Today is the first day of the semester, and what's the better way to start it but to listen to two wonderful talks that we have arranged for you. We shall listen to the talk first, and while listening, you may pause your question on the Q&A window. After both talks, then only I shall read out your questions for the panelists to answer. When you type, please begin with your name, where you from, and then type which panelist you forward the questions to. You may also ask directly by unmuting your mic, but only after the talk. Thank you. Yes, let me remind everyone again to please mute your mic unless the speaker requires your immediate response. Okay, without further ado, let us begin with the first talk, Mathematics for Academics. Let me introduce to you to the speaker, our none other than Associate Professor Dr. Jan Labadin. Jan Labadin is an Associate Professor at the Faculty of Computer Science and Information Technology, as well as Senior Research Fellow at the Institute of Social Informatics and Technological Innovation, Universiti Malaysia, Sarawak. She received her PhD in Computational Mathematics, specializing in field dynamics from the Imperial College of Science, Technology and Medicine, London, UK in 2002. She has since actively contributed her expertise mainly in the modeling of dynamical systems. This is evident from the research students she supervised as well as the research grant that she led. Up to now, there are 7 PhD graduates and 9 master graduates, where Associate Professor Dr. Jan is the main supervisor. She has completed 3 MOHI research grants, which is national grant, and 5 UNIMAS research grants, of which she was principal investigator. Last year, she was involved in nation COVID-19 outbreak predictions for Movement Control Order MCO implementation in Malaysia. Associate Professor Dr. Jan, we are all ears.
Thank you, Dr. Sze San Nah, for the very colorful introduction. Okay, let me share my slide first. Hopefully this works because we didn't try out just now, but I'm sure shouldn't be a problem, right? Are you seeing this?
Yes.
Okay, so very good afternoon to our invited speaker, AP Dr. Norma Alias. Thank you for joining us. Dr. Sze San Nah, our moderator for this event, and to all participants to this International Day of Mathematics 2021 at UNIMAS. First of all, I would like to take this opportunity to thank all my colleagues from the Computational Science program, the Faculty of Computer Science and Information Technology UNIMAS, for successfully organized this event. And I also thank Dr. Norma, my good friend since year 2008. Thank you, Norma, for joining us in our inaugural celebration of the International Day of Mathematics. And to all of you present here today, thank you for taking the time to be with us and to know a little bit of mathematics used in academics. And I'm sure Dr. Norma also will have her own session later on. Yeah. As mentioned by Dr. Sze just now, my PhD was in fluid dynamics, but I have started working on disease modeling 5 years after returning back to Malaysia. Okay, as a motivation, let me first start by asking all of you, who knows what is that shining in the middle of this chart? I guess no one wants to say anything, right? Everyone wants to keep quiet. Yes, it is computational science. Computational science is a discipline concerned with the design, implementation, and use of mathematical models to analyze and solve scientific problems. Basically, the term refers to the use of computers to perform simulations or numerical analysis of a scientific system or process. Yeah. So the scientific process that we are going to look at today is on epidemics. Yeah, the disciplinary modeling that we're going to look at. So I will be sharing with you how mathematics is used in predicting and projecting the cause of a particular disease. I hope to give you a flavor of the basic concept in disease modeling, and then move on to selecting few mathematical models that we have formulated here at the faculty and discuss the simulations. Okay, now, another question for you. Who knows what's the difference between prediction and projection? Yeah, you see here, a prediction is a statement that something will happen in the future based on what is known today. In this sense, a prediction is most influenced by the initial conditions, the current situation from which we predict change. Okay? In contrast, a projection allows for changes in the set of some conditions that might influence the prediction, creating what-if statement. If this we do, then what will happen types of statement. Yeah. So for example, when we first predict or predict what happens to COVID-19, when the first case come in, based on our conventional SEIR model, I will tell you a little bit about SEIR later on. The prediction is that the daily total active cases would have reached peak in 2 months' time, okay, if we don't do anything, if there is no interventions. However, okay, so this is what we predict, yeah. However, if we do impose some interventions such as tracing of close contacts, quarantine, isolation, then the peak is slightly postponed. So you'll notice that it's postponed a little bit. Okay, so here the peak is sometime in late April, but in the second graph, it's pushed to June. Yeah, and the magnitude is a bit lower in comparison to if we don't do any interventions. Okay, so for our stakeholder, our client would be the policymaker in public health. The aim is to prevent outbreak and to come up with intervention to flatten the curve. Okay, so to prevent and to intervene, however, one must predict, thus project. Okay? So therefore, predicting and projecting on the cause of any disease would have to be based on assumptions and hypotheses. This means that we have many hypotheses, as what I showed you here, and each hypothesis will result in one model. And in the model, we will have some parameters of which we need to calibrate, as the goal is to actually mimic the real world. Okay, and our real world is in the form of actual data that we collect from the real world. Yeah, so the best fit between the simulated data against the actual data means the least difference between the two. There may be cases where one hypothesis led to a more complex model, as you will see later on, and yet resulting in somewhat the same. Therefore, it is better to start simple. Yeah, and clearly it depends on what you want. What is your what if questions? Before we move further, as a computational scientist, we must first understand the problem domain. Yeah. So in academics, yeah, what do the public health wants to predict? Now you may have already heard the term R naught, yeah, which was used by our Director General of Health in his press statements. So I'll give you a little flavor of what this means and few more seems like a lecture, and then before I move on to our models. Yeah. So R naught is the basic reproduction number, which is the number of cases on average an infected person will cause during their infectious period. This means that the number represents the maximum epidemic potential of a pathogen. Okay, so it describes what would happen if an infectious person were to enter a fully susceptible community. So this is a very important parameter. So if R naught is more than 1, then we will have outbreak. If R naught is less than 1, then infection will die out. Yeah. So this given here is just an examples of some of the R naught or other diseases. Yeah, so as you can see, measles is very contagious, and COVID-19 we found it to be between 3.3 to 5.7. Yeah. Okay, so this cartoon here shows what it means by reproduction number, the basic reproduction number. So as you can see, the cartoons here shows that the R naught is 2. Yeah, so at every time it can infect 2%, and so on and so on. So first generation, second generation, and so on. So I'm sure you know this by now because COVID, the pandemic is still on, and these are the terms that has been used. Okay, so what makes people get infected? We know that a susceptible person will get infected when he or she has some form of contact with the infected person. So one of the parameters that we are interested in is the force of infection. Okay, so this is called the force of infection here. Yeah? So the force of infection depends on the number of infectious individuals in the population and how frequently they contact other individuals. Yeah. Okay, more lectures, yeah, a little bit. So in modeling, we like to start simple. The simplest assumption that we could make about contact is that individuals mix randomly, which means the chances of 2 individuals meet or have contact is the same regardless of their age or other characteristics. This is what homogeneous population means. And when we assume that change only occur in time, for example, then the mathematical model that we formulated will be ordinary differential equations. Okay. On the other hand, when mixing depends on age, occupation, gender, social group, or some characteristics, then the population is assumed to be heterogeneous. Okay? Usually, with such assumption, change occurs not only in time, but also in space, in location, and therefore the model formulated will be a partial differential equation. And sometimes we will be using individual-based model or agent-based model, and sometimes network models. Okay, so when we want to address the homogeneous assumptions, we want to make it more heterogeneous, because heterogeneous is more nearer to the real life scenario. Yeah, so then we will be working on these type of models. However, that type of models are quite complex. Yeah. Moving on to formulation of a model, we have to decide what model should we begin with. A deterministic model describes what happens on average in a population and does not incorporate the effects of chance. Yeah, this means that the model depends highly on its initial values, and so we will have whatever comes in, X, and then we will have one output, Y. Okay. However, in stochastic, it allows the number of individuals who move from one state to another to vary through chance. For example, the rate at which people are infected or infectious individuals recover from disease may vary randomly. The health state will be different. Yeah. So therefore, with stochastic, the input, when you input into the model, you will have very your output will be vary. Okay, so you end up with more than one output. Okay, so that's the difference between stochastic and deterministic model. Okay, so for simplistic one, we usually use compartmental modeling, where it says rate, we follow Balance law. Okay, so the total rate of change of a substance, for example, is equals to rate in minus rate out. So that's the simplest one. So I will show you now, very simple, okay, just to let everyone knows what does compartmental modeling is. All right, so let us start by considering the population is divided into two populations, susceptible and infectious, for example. Yeah, so susceptible individuals will become infected and move to the infected population. An infected individual will remove from this compartment, the red one, if they die or they recovered from the disease. Yeah. So we will have, then we transform these compartments into word equation to represent each of them. So therefore, since we have two compartments, then we will have two word equations. So for the first one, for susceptible, we have the rate of change in number of susceptibles is equal to Y0, 0 because there's nothing coming inside the compartment, and then minus the one going out from the compartment, which is the rate the susceptibles being infected. Yeah. So for the red one, the word equation is that the total rate of change for the number of infectious is equals to the rate it comes in. The rate it comes in is the same as the one that leaving the susceptible. Yeah. And then minus the rate infectious moving out. Okay, being removed. Okay, so then we need to translate this into some mathematical form. What is rate of susceptibles infected? So we will have to make assumption that the rate of susceptible getting infected by one person is directly proportional to the number of susceptible. So that this is what we mean. This is for one infected person. So therefore, we will have a constant of proportionality there. Then if it is the number of infected person will be many, then it becomes, you will multiply that with the number of infected, which is beta Si now. Okay. So therefore, for this word equation, we will translate it into this differential equation. Yeah, the SDT represents this rate of change in number of susceptibles equal to minus beta Si. Okay, and the same goes with this because the rate in will have the same term. Yeah, and how about rate infected and removed? Okay, so that we'll have to have an assumption again. The rate of infections removed is directly proportional to the number of infections, for example. So we have this. So there we are. This is our model. We have two equations that represent for susceptible and infected. Yeah. So these are the two equations. This is our model. This is a disease model for SI. Very simple. Yeah. So with this, we can solve this. Yeah. But how we solve, we need some initial values. Definitely, we need initial values. And how do we get the initial values? So if you were to work on a particular population, say for example in a school, so you will need to know what is the total population of the school. Okay, and then you decide on the day when the first case comes in. So if you know how many in the first day, then you have your values. Okay, so that becomes an initial value problem. Yeah. So obviously you also need some values for your beta and gamma. Okay, so for this case, what is beta? Beta is the transmission coefficient, the probability of contact getting infected. Okay, and gamma is the removal rate or the recovery rate. Yeah, so this initial value problem can be solved using some numerical methods that we have Euler method, Runge-Kutta method, and there are many other methods. Yeah. Now, with this, we can use some scientific computation. We have Maple that you can use. They all have a built-in function that does all these numerical methods. Okay, so we have MATLAB. You can also use R programming language to call the built-in functions and to solve for you. Right? Just give values for the initial values and the parameter values, and you will get it. Yeah. So this is the output of the one that I show you just now, the SI problem, SI model. Okay, the values we put in is shown here. So for this case, we have the initial value is 99. The for infected is 1%. Okay, and then you may want to compare this with actual data. Okay, what data should we use? Okay, so we should be using, okay, sorry, for this case, I use these values for beta and gamma. Right, since we are working on disease, okay, so what data do we need? What data should we compare it with? For this case, you will need to use daily active cases. Why? Because our model is a continuous model. That means at every time step, there will be change in our dependent variable, and our dependent variable are S and I, the susceptible and the infector. And we know from our model that the S will continue to decrease. Okay, so from here, as you can see here, this is our S. S is decreasing. Okay, the number of susceptible is decreasing. However, it will not decrease until 0. So therefore, not everyone will get infected. Okay, and the red line here is the infected. Okay, so as you can see from the beginning, it will increase and then it will reach some peak and then it will go down, right? So this is the area of outbreak. And we want to know when will it reach the peak. Yeah, and obviously we want to reduce the number of people getting infected. Okay, all right, here I just do a very quick, I just use SI model and then compare it with actual data for the first wave for COVID, yeah, from 25th January to 24th February. So here I just use SI, so it's not that good, but still okay. Yeah, as you can see that we can see the when it is peaking and when does it start to decline. Okay, so imagine if you don't have all this data yet. Okay, so the next wave coming in, so you can already see when it will peak. Okay, given the parameters that you have already calibrated, because these parameters you don't know in the first round. Yeah, so you will have to calibrate, you have to do some approximation. Okay, right, so I'm just showing you here that apart from solving the model numerically, because this is what we did here. Okay, just take our model and then put it in R, call our built-in function, and then you can solve it. But apart from that, you can actually analyze it, analyze the model theoretically. Okay, the beauty about analyzing this theoretically is that we would know whether the solution will always behave like that. Okay, because remember, when we solve it numerically, you will need to give values for the initial values as well as the parameter values. But how do we know that it will always behave like this? Okay, because you will need to have a different set of parameter values, right? So that is why you will need some theoretical solution or theoretical analysis. Okay, so it seemed there were always certain, if you look at here, the susceptible approach some finite number, and it seemed there were always certain individuals who never contracted the disease, like I said just now. So we can actually find equilibrium solution and find the direction of the solution in a trajectories in a phase plane like this. Okay, so this is a phase plane. So as you can see, you will notice that the susceptible is moving towards some finite values here, right? So this is a trajectory, yeah, the trajectory that depends on these differential equations only, nothing numerical here, okay? And you can also find out, okay, so you notice here, this is infected and susceptible, so there's no time dependent there. So what happens is actually you can use chain analysis, okay, and you can do this and get rid of time and find out and solve this new differential equation now, and find out what is the solution of I, or the expression of the infected given the susceptible, right? So from here, you can find out, or you can sketch the I and S phase, okay, the phase plane here. Okay, so we can find the turning point as well for this phase plane simply by some mathematical way. You can let di ds equals to 0 and solve for s, and then finding out what is s as I tends to minus infinity, okay, and so on. And then you can find out what is the turning point here. Okay, so that means, let's say if you have initial condition here, so in here, and you move, so you can see that the susceptible is decreasing and the infected is increasing at that turning point, and then it will decrease. Okay, the infected will be decreasing, susceptible still decreasing, yeah, and it will reach a finite value for S, and infected will be 0. Okay, so this turning point is very crucial, because, okay, what if we start off with our susceptible to be in this range, which is less than gamma over beta, if we were to start our susceptible here, then there is no outbreak because our infected will surely be decreasing all the time, okay, based on this theoretical analysis. Yeah, so that means if we are able to vaccinate this number of people, which is less, okay, making sure that the susceptible is less than this value, then we know that there is no outbreak. Okay, so that is the most important thing about this. And what is that? That is actually our reproduction number, okay, the one that I mentioned just now, because you can actually put this and putting it that R naught is greater than 1. Okay, if you let R naught is equals to S naught multiplied by beta over gamma. Okay. So, but this is SI model. This is very simple SI model. And for more complex models, you probably need disease-free equilibrium, next generation method, and so on. Yeah, so it is not that easy per se. This is quite easy because we are using SI model, yeah, susceptible infected model. Okay, so now I'm gonna share with you what I have done with the Ministry of Health. So we are privileged to be working with, I still have time, right? With the Ministry of Health. So we developed or we formulated a model for COVID, which is based on SEIR. SEIR is what you saw just now is just SI. So SEIR is where we have exposed and recovered. Yeah. And apart from that, we also introduce more compartments because of the intervention that the Ministry of Health imposed, which are the trace negative. Those people, the close contact, these are the trace. So the PUI, yeah? PUI, the person under investigation, however, they are negative. Okay, so they are under T, the population T. And then we also have EQ. EQ is the PUI as well, but they are positive. Okay, so because there are certain time when they are isolated, as soon as you are found to be PUI, you are isolated. Okay, you are asked to be quarantined, and then you are asked to go to do your swab. There are some who are negative, some who are positive. So this is where we put in or segregate them into these compartments. And then we introduce infectious. So infectious is those who are positive. They have to be moved into the hospital, yeah, or the one that the frontliner will look after. Okay, those nurses and doctors will look after. Okay, that they are the IQ. All right. So these T, EQ, and IQ, they are all those that the health people manage to get. But they are, unfortunately, people who, especially asymptomatic, that are not able to be traced. Okay, so they are in the E and the I. Yeah, so our model managed to do this. Okay, or try to capture what is the actual that is happening right now. Okay, of course, as you have seen just now, we translate this compartmental model. Okay, so this is a compartmental model. Translate this into mathematical equations. So it is a bit more complicated in comparison to the SI model, obviously. Yeah, so here we have, because we have introduced this many compartments, therefore the equations become this many as well. And the parameters involved, we have introduced a zeta, okay, that corresponds to the social distancing. And we also introduce a kappa here to correspond to individual that follows the SOP. Yeah, so all that we put it into our parameters, okay, in here. So that is why it's quite complicated in the sense, okay? But it all actually come from the compartmental model that I have shown you earlier on, yeah? All right, so how does it look like? So from there, we use disease-free equilibrium, and we manage to get our R0. Okay, well, basically, this is R effective, huh? Because we have already imposed intervention. And you will notice here, the R0 is directly proportional to the zeta, which means that if zeta, as I mentioned just now, is the social distancing. So if the number of contacts done by the infected is large, so it means that you keep on contact people, therefore your R0 become big. Yeah, so as you know, what does R0 means? R0, if R0 is more than 1, the outbreak will go off. You see? So this really shows that social distancing is very important. If you don't distance yourself, okay, then the R0 is huge. Okay, so this is what happens. We managed to do this, and as mentioned by Dr. Sze just now, I work with Ministry of Health, especially in these phases, yeah, in these phases. And we published this paper as well when we formulated that model. And that's when the Director General, I mean, the analysis done here helps them to decide whether to extend MCO or not. Okay. And apart from that, we also develop, because I keep on trying to see what's happening to the cases. So we develop this web-based tool. So you can actually go there. Yeah. So I put a QR code there for you to access to this COVID-19. We developed this web-based tool. So you can see what's going on in Malaysia. We also did that for Sarawak and Sabah, actually, for those who want to look at how we progress. So we put in the R0 there as well. Okay, so remember, if we do not want the disease to be around, we want our R0 to be less than 1, obviously, yeah? Okay, this is just to show what I did using that model. So in here, I wrote a report every time to Ministry of Health. The content, actually all these reports is available in that web-based, in that tool as well that I showed you just now. So in here, as you can see, because the one that we are looking at is gamma, zeta, kappa, yeah, and also the R0. So before MCO start, you see the zeta is very large, means that no one is doing any social distancing. But when they start the MCO, it gets better, okay? And as moving on, we see the compliance is quite good, right? So, but when it started to lift, okay, because when we move to MCO phase 4, the zeta is getting large, yeah, and then CMCO obviously. So the only way to control is with the kappa. And remember, what is kappa? Kappa is the how you look after yourself, your personal hygiene. You need to wash your hands all the time, sanitize, and all these things. Wear your mask. Okay, so that's the reason why that is kappa. Okay, so even though you go, we don't have MCO, means that we go to work and all those things, but remember your face mask still on, because if not, we will still be having a pandemic outbreak, yeah? So this is how I wrote in my 5th report to the MOH. So I said, okay, yes, it can be CMCO, but the kappa needs to be very controlled. Yeah, so if there's only less than 40% of the population following the SOP, then this is where we are. The kappa, I mean the number of cases will still continue. So you look at this. This is somewhere in October last year. Yeah, look at this here. And I did mention to them that if we don't do anything on it, stress on the SOP, then we will still be looking at increase. Yeah. So this is what is happening right now. So as you can see here, this is starting in December. Yeah. So when we were in October, it keep on increasing until in January somewhere where we reached the peak. This is whole Malaysia. I'm not talking about Sarawak, because Sarawak there is a little bit delay. Yeah, you can see that in my COVID sim. Yeah, so now we have already declining, okay, decreasing there, and vaccine comes in. So vaccine comes in, then our model change. So our model now change, where we include in vaccinated population. Yeah, and we saw, you can also play around with my COVID sim and change the values in there, and you'll see that if we are not careful with our kappa, means our SOP, then this will go up again. Yeah, so that is where this comes in, and that is the COVID model that we do, right? I do not know whether I still have time. I still feel you let me know.
Yes,
Okay,
yes, yes,
Sana.
you still have time.
Okay. All right, good. So next model that we have here is where we work on rabies. Okay, so obviously with rabies, we are working together with, I mean, the infection will comes in with dogs. Yeah, so the dogs must come into the model, obviously. So not only we have the human, but we also have the dogs here. Okay, so we formulated it in this way, where the human follows SEIR. So there is a exposed and infected, and there is a recovered. Now, unfortunately, with rabies, once you are infected, you are not be able to recover. So that is why from infected, there is no arrow going to recovered. Yeah, so this is a very dangerous disease. So, and how you get infected is actually from an infected dog. So that is the reason why we have this arrow here. Okay, so the dog, we also follow SEIR as well. Okay, so in here we solve it. We introduce some parameters as well, and this is the simulation. But with this, it is quite how to say. I didn't show the one that compare with the actual data because the data is quite not so many. Yeah. So you probably see that it is not as nice as what you saw for COVID. Okay, because COVID, we have so many data, so many infected cases. So it's easy to calibrate the parameters. But with rabies, because there are not so many, therefore it's quite difficult to calibrate. However, we will be able to see or get some insights on how the disease moves. Okay, so this is the what I want to say about this is that we did some sensitivity analysis and showed that dog vaccination rate, when we vaccinate the dogs, it's the most influential parameter. and the basic reproduction number is estimated to be higher than 1. Therefore, the disease will persist. Okay, so as you can see here, you'll notice that yes, the disease is persisting. Yeah, it stays on. So we suggest that there is a need to increase the coverage of dog vaccination and reduce the number of newborn dogs. Means that we will need to neuter all the dogs. Okay, so as it shows in our simulation that it would be more effective strategies, these two, yeah. So vaccinate dog and neuter the dogs. Okay, this is the most effective strategy to manage the current outbreak in Sarawak. Okay, moving on, these are other models that I did in the faculty. So we did on hand, foot, mouth disease as well. So we for hand, foot, mouth disease, we start off very simple SIR, and then we realized that the disease can stay in the stool. Okay, so the virus can stay in the stool. So therefore, we have to change our model a little bit to incorporate that. Okay, and we saw that it is better in predict formulated model for malaria. And malaria, as you have seen in rabies as well, we will need to introduce population for mosquitoes. Yeah, so we did that as well. And then we realized, okay, with mosquito-borne diseases, we can actually create a generic model. So perhaps with this generic model, we can use this generic model for different mosquito-borne diseases. Yeah, so we tested out. So in here, as I mentioned just now, I like to start simple. So we use SI only for human and mosquito SI as well. Yeah, so SI models for both. But obviously, it has many parameters for each rates. Okay, for each rates, it has many parameters. And then we tested it out for Zika, dengue, and malaria. So far, Zika and malaria quite good. However, with dengue, it's a bit, no, sorry. Zika and dengue is quite good. Malaria is not so good, perhaps because of, there are some, because each disease has its strains. So it has a different type of virus. So therefore, we probably, because that data that we get for malaria may not be representing a general one. We cannot have a general disease. Yeah. Okay, so all those in compartmental models, yeah, the one that I introduced to you, and then for this type of models, we have to assume that it is homogeneous. I already mentioned to you what is homogeneous, right? So we also did network models because we are addressing the homogeneous assumption. Yeah, we want to make it more heterogeneous. Yeah, so our model will be of micro level instead of macro level. Yeah, so we introduce a network model. So we formulated malaria and dengue using a network. Okay, so instead of looking at them at a macro level. So here we try to come up with a network of human with the locations, the places where they have visited, the patients visited the locations. Yeah, and then we use HITS, yeah, HITS algorithm, a searching algorithm, to decide which of these location will be of the prime location, the location at which the source of infection comes from. Yeah, so we did that for malaria first, and then dengue, and we came up with a web-based tool for dengue. Okay, and we come up with this tool that shows the hotspot. Okay, because when we talk about ability to find out the places where the source of infection is, then that means that's a hotspot. Yeah, so that's what we have here, and also we show some statistics. So this is at the moment we try to deploy it. We are working with the Institute for Medical Research to deploy this with the Ministry of Health. So I'm still waiting with the okay from them for us to use this, yeah, the dengue hotspot detection tool. We also did individual based model, again addressing the assumption of homogeneity. Okay, so we want to make this more of heterogeneity, means that we are looking at each individual, so therefore we use individual based model, or maybe some people may prefer agent based models. Yeah, so we use agent based models to model the disease. Okay, so for here we say that when we put in vaccine, because each person will see whether to vaccine or not to vaccine, you know, so this decision done by each individual can be incorporated into the model. So we use game theory to put in the behavior of the human being. So this is what we did for this case, and we showed that in our paper here. So as you can see here, it has many lines. Obviously, like I mentioned just now, when you are introducing stochasticity, then this is what happened. Yeah. Right. I think I'm already coming to the end already. So I just want to say that we started a disease modeling workshop since 2014. So if you want to know more about disease models and then want to learn, we try to do it every year, but last year we didn't do it because of the pandemic. I'm not sure yet for this year. We'll see how. But these are our core researchers for this workshop. And I would like to thank all my core researchers for all the models that we formulated at the faculty. These are the people that have been working with us, and our postgraduate student as well. So I thank them for all the work that they have done. Okay, and the public health people as well, as mentioned in here. Okay, so thank you very much for listening. I end my talk with this very true quote by Jen Cates. No model or set of models can serve as a crystal ball, yeah, to predict what will happen in the future, but they can shed a light and provide much needed perspective on aspects of the epidemic. At least you will know, you know, how the pattern will look like. It may not be exactly the magnitude of or the number of cases that you will get, but at least you will somehow see that yes, it will go you know, outbreak, it will increase and then it will decrease when sometime 2 weeks from now or 1 month from now, something like that. So at least it will give you some perspective needed for decision making. Thank you very much.
Thank you, Dr. Jen. Thank you, Dr. Jen, for that insightful talk. Thank you for your sharing that using the COVID-19, I was once the PUI, then I now understand that where I was, and then now I know that wearing a mask is actually a kappa, and then social distancing is a zeta, and now I know that how important all these things, this practice actually can be put into the modeling and help us to predict. So let us wear our mask, wear our kappa, and then implement our zeta so that we can pull our R naught down. So
Yes.
yes, thank you very much. Okay, let me remind the audience again to keep your question coming into our Q&A window. Okay, next. Let us move on to our invited speaker, Associate Professor Dr. Norma Alias, who is joining us all the way from the Mathematical Sciences Department, Faculty of Science, Universiti Teknologi Malaysia. That's my university actually. Thank you, Associate Professor Dr. Norma, for taking the time off to be with us today. Allow me to introduce Associate Professor Dr. Norma Alias a little bit, just a little bit. If I'm going to read all her profile, we might need an extra hour. Okay. Associate Professor Dr. Norma Alias is currently the task force of UTM Online Teaching and Learning, Associate Professor of Mathematical Sciences Department, and 12 years as an Associate Research Fellow of Ibn Sina Institute of Scientific and Industrial Research, UTM. She completed her PhD degree in industrial computing, specializing in parallel computing in 2004. She has since specialized into diverse fields, including mathematical modeling, big data simulation, industrial computing, scientific computing, high performance computing, shared distributed parallel computing system, group computing, and software development. She has successfully supervised 13 PhD and 32 master graduates. Now she is supervising 8 PhD students, 30 master students, and 2 postdoctorate fellows. Dr. Norma has excellent academic and research track record, having published over 200 publications, and has held a number of editorial board membership for 8 international and national journals. Also, she is the year 2016 and 2017 Venus International Woman Award winner for Distinguished Woman in Science. Associate Professor Dr. Norma Alias, the floor is yours.
Good evening. How my voice? Clear?
Yes, yes.
Okay, very good. Thank you, Dr. Sze San Nah, the moderator. Very colorful introduction. Okay, to myself. Thank you very much. Thank you to Associate Professor Dr. Jane Labadin because inviting me to join the Mathematics World Day now. All right. And then thank you to Dr. Sarah as a host for this session, right? Let's share my screen here, right? All right. Okay. And then thank you because Universiti Malaysia Sarawak inviting me as a speaker today for International Day of Mathematics, Mathematics for a Better World, right? So my talk today is on mathematics in big data. Okay, people always want to know what is a big data. What is the relationship between mathematics and big data? All right, so please use your handphone and scan the QR code. Let's share your knowledge about the career, okay, or for mathematician and statistician in big data. If you can share, or I can go to the chat. Okay, I'm stop sharing, right? I go to the chat and then I post the link. You can go to the chat, right? I can post my link, okay? All right, if not post, okay, we can also share screen again and then go to the QR code, okay? Right, so you can use your handphone and then you can write a words, okay, just a words, all right? And then let's we go in, okay, what is the feedback from all of us? All right, my content today is explaining what is a big data, what is a big data analytics, okay, the comparison between data modeling and data simulation, the roadmap, of the mathematics in big data. All right, the roadmaps of the mathematics in big data, mathematics in big data for 2021 and the future of the data science and data analytics, okay, which is people, all of them are from mathematics background, statistic background, and computer science background. And then the next is a conclusion. All right, so what is a big data? That is a main issue here. All right, every day, okay, you have handphone, okay, you also have many device, you receiving, okay, a lot of types data. For example, okay, in your handphone, maybe you are using social media. For example, you are using Telegram or WhatsApp. All right, you are receiving, okay, for 41.7 million per minute in 2021. All right, so these are people all the world receiving 41.7 messages per minute. All right, how about the Netflix? Okay, I know people looking the video, the movie and so on. That is 404,000 hours people doing video streaming, okay, to search the movie that they like. And others, for example, TikTok, Instagram, all increasing. So we are receiving a lot of data. For example, okay, we are receiving a huge value of data, all right? For example, terabyte, gigabyte, petabyte, zotabyte, yottabyte, all right? All right, and then the velocity, how speed the data come into your directory, to your cloud, to your handphone, and so on. And then the important now is a variety of data. Okay, there are so many data, maybe in the volume, in the wave, in the images, in the form of the DOC file, Excel, and so on. All right, okay, we want to see the veracity of the data. For example, how messy the data, how full trustness of the data, and the quality of the data. Visibility is an intention and prominence of the data. And then viability is how the data success to produce the prediction. Just now, okay, Assistant Professor Dr. Jade, okay, asked a question about what is the difference between prediction and projection. To do a projector, we need to do a successful to predict the outcome, right? And then this is a type of the data that I'm going to focus, 7V. Last time is a 3V, all right? Okay, the data we can divide into two, all right? For example, the video that you search, all right? And then the message that you receive, the TikTok that you, play with is an unstructured data because there are so many types of data, images, audio, video, all right? And then MOV, POV, MMO, MP4, and so on, all right? However, okay, the structured data is based on numbers, dates, and string. All right, so this is very structured. Okay, now, how we generate the data? How we generate the data? All right, for example, okay, I love if I can go to this video, all right, I'm stop sharing. I'd like to share my video, okay. If I can share my video here, all right, I go to the video, and then let's play around, okay. So now let's share the video if I can share it. All right, so now, okay, you can see here, there are many types of data. Images, okay, data personal, which is sometimes looking for the data breach or data leak, all right. A file of data, we convert to the digital form. And then there are so many numbers involved where we convert the images, the wave to numbers, because the numbers is very meanings to the mathematician. All right. So for example, here I have so many questions, and then I collect the data, and the data, okay, can be analyzed, and then we factors the data. Okay, we put the data into a number of factors, into a number of parameters, into a number of meaningful factors, and then we can get the weighted parameter to integrate between the factors. Right. Okay, for the images, for example, we are using GIS, Geo Information System. We can see, okay, very drastic about the changes of the land, the changes of the river, the development of the area, which is very important for the town planning, especially to develop the smart city. For example, here we are looking for the smart city full of the device connected each other. All right. So when we deal with the data, okay, we deal with the device, we deal with the sensor, we deal with the images, for example. All right. So we need to convert, okay, do some analysis of the data, right? So now, okay, I share again the PowerPoint here. All right. So this is a question, okay, we need to answer how the data generate. All right. For example, okay, in the factory, okay, there is a trillion data generate, okay, sample generate per year. And how we want to analyze the data to make sure this digital transformation pipeline, okay, will be a benefit to the companies, especially to look, okay, data for the business growth. All right. For this, for example, this is a cosmetic, okay, factories. They are developing 4 trillion sample per year, biotech, okay, biotech companies. So they start looking which product, okay, which give a very good, okay, income to the company. And then you can see here the data sources, okay, there are so many types, okay, for example, from your handphone, from the smart grid, from the smart sensor, from the medical equipment, from the digital camera, they will contribute to the big data. All right, big data, for example, Tera, Jota, okay, Zeta, Penta is considered as a big data. Okay, and then we start, okay, analyze the data. Maybe we are using mathematical modeling, like Dr. Jane just now explained. Okay, some of them they are using a machine learning, okay, using artificial intelligence to predict, to do the monitoring, to do the observation of the data. All right. And then in this case, we need a tool because the data contribute to the big simulation. So we need to use high performance computing or large sparse cloud, okay, or high speed simulation, high speed processor to support the huge simulation. All right. So now I invite you to do the transition from using a small data to a big data. Why? Because the impact is very good. Okay, for example, you can get a high resolution, okay, very good resolution, accurate prediction, real-time observation, and then the visualization can be 2D, 3D, and multi-dimensional visualization. And then the precise or negotiation between the practical and the prediction is a converge to the what you want, okay, what we want, okay, is a good prediction. All right, this is decision making that we want. All right, so now as a mathematician, as a statistician, what is our function during COVID-19 pandemic nowadays? During people, okay, looking for the job, during people stay at home, work from home. Yes, okay, mathematics and statistics are really important to make a decision. When the data comes using, okay, the data engineers, okay, collecting data and then do a cleaning, do the, okay, reducing a noise, all right, and then do the reduction, dimensional reduction. So the data will be analyzed using the data simulation, mathematical modeling, or big data analytic to get the decision. Okay, so this is very important nowadays. We analyze data to make a decision. So in this case, you can see here, all right, this is the Venn graph. Okay, data analysts and data engineers, data scientists is integrated for multidisciplinary area. For example, mathematics, statistics, developing the algorithm, software development, and data communication between cloud and cloud, between device and device, between sensor, or sometimes we call as an Internet of Things. Okay, this is a journey to the fourth industrial revolution where people looking for the cyber physical sense. Okay, cyber physical system. All right, Dr. Jane just explaining their software about how to predict, okay, the pandemic, okay, with the specific parameters. All right. So now I put a line between statistics and mathematics. Okay, what is the statistic and what is the mathematics? Statistics is more on the, okay, stochastic, deterministic, And then mathematics is more on the continuous time, discrete time. Okay, just now Dr. Jane, looking for the initial and boundary condition. All right, and then they start doing the numerical analysis to do the mathematical modeling for the specific grand challenge application, for specific application. All right, so now people looking as a mathematician, as a statistician, what is our future job? Okay, so now I list already the future job. I know, okay, you are very, open mind to the online teaching and learning. All right, you are exposed to many software, open source and licensing software. However, for this, style of teaching will be give you a good impact. What is your good impact? All right, okay, good impact for industrial revolution. You are going mathematician and statistician. You have a bright future to be data analyst, data scientist, data provider, machine learning operation, software developer, all right, and then system developer, for example. There are so many job spec for the mathematician and statistician. So now, why mathematics involved in big data? Okay, this is the question. Why I'm mathematician, my student mathematician, why they need to involve in big data to get a better job? All right. So why? Because, as a mathematician and statistician, we are always deal with the data. We always deal with a complex model. Dr. Jane just explained about the complex model. So we are really know about the ODE, PDE, calculus, algebra, statistical, multivariate. We are always deal with this function, with this knowledge, with this skill. All right. So now, so what we do is, as a mathematician, all right, which is give impact for a better world as our thema for International Malaysia world nowadays, is to engage, to converge the approximation solution to the real or to the exact solution or to the analytical solution. Okay, these are the words, all right? So we play with the theorem, corollaries, formula, rules, to make sure that our prediction converge to the exact solution. All right. So now, when we deal with the data, I show you so many types of data. If you are using GIS, for example, Google Earth, for example, you are given 2D, 2D images about the specific location. And then if you are dealing with the electroencephalography or EOG, they give you a wave about the brain wave, alpha, beta, gamma, for example, theta, delta, 5 brain wave. And then you can predict what happened to the people stay at home during pandemic, all right? And then with you deal with the very nano, we call as a nanotechnology sensor or ESAM. So we can also deal with the how we can create, we can predict the cell growth, the abnormal cell growth. All right, so meaning that we know what happened to the cell to be a cancer cell or melanin or any stages of the cancer. All right, so now when you deal with the handphone, right, you deal with the handphone. So meaning that there is a multi-layered device component, all right, and then chip, for example, heatsink's, Swiss's, Swiss, and then transistor, transformer inside the handphone, but we cannot see from the naked eyes. So meaning that, all right, there is a mathematical modeling to represent how, we can see the temperature behavior, all right, or e-waste inside the handphone. So in this case, mathematical modeling using the ODE or PDE can engage, can visualize, for example, here the temperature behavior, the density, all right, about the changes, at the specific component in the device itself. All right. I know people now quite active using the wearable device, for example, watch, wearable watch to detect the BP, the beat, the blood, the temperature of the body. All right. So I'm also doing a research with my student. All right. Where we can detect the eyes movement and muscle around the eyes. All right. We put a sensor around the eyes, and then we collect the data using electroechography or EOG. All right. And then the data transform, the signal data transform to the digital, and then get a numbers. Okay. After getting a numbers, we need to analyze using machine learning or deep learning based on the volume of the data. All right. So when we deal a big data, okay, we need to have a huge memory. We need to have high speed processor to simulate the machine learning and testing process. All right. So I'm using GPU, CPU, the latest, okay, the new generation of the high performance computing system. And then we can visualize what happened to the eyes movement after a certain hours. Okay, for example, student, they read a lot, they are looking at the computer a lot, engage with the online teaching and learning, and then the driver, okay, drive a long, okay, distance. So the eyes will be weak and weak. So what happened to the eyes after a few hours? All right. So that's we are dealing with the machine learning. We are developing a pipeline of data mining. Okay, the pattern, okay, the recognition of the data, and then we do the predictive analytic. In this case, okay, we are using forecast customer behavior for the future development. All right, there are two method that we deal, okay, what we call as a big data analytic. Okay, that is a machine learning and deep learning. Machine learning is small data, deep learning huge data. So that's why we need a big data to get a good predictive model. All right. So now, okay, as I know, okay, when we have a data, we need to divide into two parts. The first part is to learning process. Okay, it's almost 75 to 80% we use for learning process. 25% or 20% we use for testing. So we need to make sure that the graph for learning and testing should be in the synchronized pattern. All right. So now, for supervised learning, or we call as a task driven, okay, so we do the task driven to generate the classification, or we do a task driven for the multi classification. To do a regression, we divide a data into two groups, all right, A and B, all right, and then the next is assembly. All right, for unsupervised learning is common, is a binary data, pure data, okay, what we call is the first data you get from the specific company, specific environment, specific device or sensor. So that is we call as a data driven. So most of, for example, here, okay, we are doing streaming and video conferencing. We are generating a voice and video every second. So that's we call as a data driven. So we can do a clustering, we can do the detection and data mining, and towards the end is reduce the noise, reduce the factors to get the good prediction. All right. So now this is a career for a mathematician in big data. What is that? Is a data scientist or data analyst. This is a career nowadays. You can work from home. Okay. However, you need to have a good in some skill. Okay, I will explain later. Okay, the data scientist, okay, the function is to perform the analytics. Okay, however, data analyst is just to understand the data, and then they use the data and they start to do the forecasting. So this is a two function of the data science and data analyst. People, okay, student will ask me a question: how to become a data scientist, how to become data analyst. I'm a mathematician. All right. So I know data scientist and data analyst is a very good future good. Okay, future for good future for the COVID-19 pandemic. Okay, where people looking for the job. So now if I expose from programming, all right. So I put one S10. Okay, for example, just now using theorem. and then start doing mathematical modeling, and then next doing a programming, and then towards the end, okay, I can get my degree in mathematics, so I can available to be a data scientist or data analyst. So they start arguing a question. Some of the question, okay, is dealing with the computer science because they are very good in programming, very good in computer science. However, they are okay minimums, okay, skill on the science and mathematical science and statistics. So we want to answer this question. All right. So now, why we need to deal with the data? Because almost okay, industry nowadays they are stuck because they are different. Okay, they are distancing. Okay, company they close because of the pandemic. Okay, 19. All right, people to get a customer is not easy unless looking through the online virtual mode, for example. So now industry looking to find a pattern of their product. Okay, so they start find the image recognition or data. Okay, what they can produce a new product, or we need to move for another or join for others. Okay, product they start looking. Okay, for example, here is a capabilities of healthcare provider. All right, so for example, faster diagnosis, and then allow doctors to suggest treatment and preventive measurement. So they are looking for the data from MRI images, from EOG, from CT scan, from the ultra mammogram, and so on. They are looking to do a diagnosis and start looking for the treatment. And then for the bankers, economic institution, they're looking for the financial sectors where data can support their decision to make a smart choice of their to launch their product, okay, during the pandemic. And then towards the end is a customer care or service industry. So that's why this is a good solution and quickly and very efficient when we can analyze the data. All right. So in this case, okay, machine learning is one of the tools, all right, to perform by human and get a very good decision making to touch the accomplish. All right. So now, when we as a mathematician in the big data, okay, they're looking for the job. So what is their function? To be okay a data scientist or data analyst. Okay, I know as a mathematician we already play around with the predictive potential trend. Okay, prediction. All right, whatever model, machine learning, deep learning that you are developed, you doing a predictive model. Second is exploring these parameters. Okay, meanings that you are from the data you can get okay what happened. For example, in Asia now, okay, they are minimized. You do flight for other countries, for other local state. All right, so they are looking other okay other job, okay, other business model. For example, okay, for example, they are using agriculture, all right, food, okay, industry, and so on. All right, so this is what we're looking. Okay, I know as a mathematician you maybe need to start from the basic. Okay, in our case, okay, we start explore to the data. Okay, how the data leveraged by the organization in industrial. We start looking, okay, how we can deal with the stakeholder, okay, to use their data and analyze and get back to their company, which is very good, okay, to their business model, their business trend, and then their business focus. All right, and then towards the end, I know you are looking also, okay, the certificate, okay, from local and international using virtual, okay, virtual learning and teaching. So try to enroll in certificate, the professional certificate in big data analytics, okay, data analyze and the data simulation and so on. All right. So now during the COVID-19, okay, we are looking for the job. Okay, this is job listed for mathematician. For example, here, all right, okay, data engineers. Okay, looking for the data and then do the cleaning, do the creating a final product. Okay, when I ask my student what they are doing, okay, most of my students said that, okay, they are doing a dashboard or reporting from the data. All right, data scientists, I know, okay, most of the student expert in mathematics and statistics, they know how to do the prediction, okay, statistic, okay, data modeling, data cleaning, data preparation, and analyze the data using the machine learning or deep learning. All right, so now there is an operator for the machine learning. Okay, they start do the collaboration, communication between the people from data science and data analysts to get a better result. Okay, all right, to get the okay, to manage the production life cycle. Okay, so they deal with the CEO and then the stakeholder, okay, to talk about the data. In this case, they need to create the software, a system to make better understanding. And this cycle is in the rotate and the feedback, good feedback from the all the function as a data analyst, data scientist, okay, data engineers, machine learning operators, and so on. All right. So now, what is the things that we need to focus, okay, to be good in mathematics and then be better, okay, better prediction for the industry, organization, or manufacturing? The first is we need to go for the new, okay, approach now. What is that? Learning and testing. Start learning using artificial intelligence tool. For example, always people say that okay, artificial neural network, machine learning, support vector machine, extreme learning, forest method. Okay, we deal with this one. Why? Because we believe that statistics and linear regression able to understand, okay, the data and able to model the problem and then solve the problem accurately. All right. So now let's relearn. Okay, let's relearn. Okay, people from computer science, for example, or other people, for example, financial, economic, they want to be a data analyst or data engineers. So they want to more, okay, critical thinking. Okay, they try to improve themselves for coding or programming. All right, they start okay communicate okay with other people from data science, data analyst. This is a good okay start. Okay, because we need to start from the scratch. Okay, why? Because industry really need okay to analyze the data for the market growth. All right. Okay, now how people start from the scratch? Okay, they need to also build their portfolio or run a small project together with the mathematician and statistician for solving a real problem. All right, and then find a mentor. Mentor here is a for people who okay, have a good background in the machine learning, mathematics, and statistics. Okay, because we want to maintain the long-term career. All right. So this is the okay journey. Okay, when mathematician working in the industry, in the organization, in the factories, okay, in the company. All right. What they do is a data collection from the company. And then they do the data preparation and start, okay, this is a start dealing with the data science. They do a training, the model, analyze, okay, the result, do the evaluation, and then towards the end, okay, retrain the model. Maybe they have a new data come in, we need to enhance the data and so on. All right. So that is a function, okay, people from mathematician, okay, when they deal with the industry. Okay, I love to, okay, I give the opportunity for you to scan again and then okay, get some words, okay, which is convenient for you, okay, for this question. Okay, you can go there and then you can see a question. Okay, try to okay, write one words. Okay, all right. So now I'm also doing some questionnaire, okay, some survey with my student. All right. So I asked them, do you know what is a big data analytics? Okay. Do you know what's interested okay, fact okay, to make sure that people looking for this career, okay, data scientists and data analysts for mathematician in big data. All right. People who are expert in the big data, they are looking for this as okay. So now I get the answer. The answer said that 60% said that yes, they know the future of their job for industrial revolution, where the industry looking using the robot, okay, automation, Internet of Things, cloud, okay, high performance computing, and so on. All right. So what is the eager want to be this new carrier? Okay. They said that okay, because they know how to play with the data, they know how to do the prediction, and they know to do the observation. Okay. This is a challenge for mathematician. Okay, for mathematics in big data. Okay. And then they don't know about the data leak and data breach, which is nowadays mathematicians should be open their mind for the hacking skill. This is integrated with the data science and data analysis. Okay, so what is that? The other skill is a hacking skill. I just present from my first slide. So now, okay, so as a mathematician, okay, they are looking, am I going to be a teacher? Am I going to be lecturers or doctors? Okay, so this is other alternative. Most of my undergraduate students, okay, they are looking for this job. All right, so now if I can share with you, I'm stop sharing. If I can go to my video feedback from my student, all right. So this is my student, feedback from my student. All right. Share with you now. And stop sharing. Right? I'm share with you the video. Okay, where is my video? Okay, now I'm sharing with you. All right. Okay, this is a feedback from my student. Okay, what's their feedback? Okay, they said that they are working with the company, investment company, banking, all right, statistic company, and then okay.
Assalamualaikum warahmatullahi wabarakatuh.
We cannot hear you, Dr. Norma.
Here, eh?
Yeah, we cannot hear.
All right. All right, so this is about my student. Okay, they are said that they are working as a data science in the company, and then their salary is around 4,000 ringgit Malaysia. All right, and then they are using a dashboard. Okay, reporting data, and then they know that the knowledge on the big data. Okay, high performance computing system about the open source software, for example, Python, Keras, Scilab, TensorFlow, Jupyter is really help them working in the company. All right. And then the other one is other student. Okay, they are very long explaining. Okay, this also okay working with the data science. Okay, and then they believe that the data is very important. Okay, to predict. Okay, to analyze, to do observation. Okay, to develop a good business model for the specific company. Right. So I'm stop sharing here. Okay, I'm go to my slide again. All right. All right. So now. All right. So now the question that we in our mind here. All right. So what is a skill? Okay, what is a skill? Okay, to be a data science and data scientist. Okay, the skill. Okay, the first is a machine learning. Okay, machine learning is integrated between the mathematical modeling, statistics. Okay, artificial intelligence. For example, okay, the method that you quite familiar, KNN, convolutional neural network. Okay, and then support vector machine, genetic algorithm, I-Forest method. Okay, extreme learning. So we need to know about the method itself, all right? And then we need also know about the multiple analytical function. All right, integrated with the knowledge in programming, in coding, okay, open source because we are working in the company. Okay, the company mostly they have no MATLAB, there are no for example, Mathematica, the licensing software, they have only open source. For example, Python, RSS, and then example Scilab and so on. So we need to deal with the SQL for database coding, and then familiar with the unstructured data. For example, here unstructured data, what is that? The voice, the video that we generate. All right. So now data scientists working in the data modeling using the data engineers, and then develop the software to deal with the stakeholder, to deal with the customer. All right, so this is very important to describe about the data and then the prediction, right? So now people looking at that, why? I'm a mathematician, all right? So to be a data scientist, how much salary I can earn? So Malaysia stated here for data, mostly my student undergraduate, they can earn around 3,000 ringgit Malaysia. They can earn around, after 2 to 5 years, they can earn to 5,000 ringgit Malaysia. For 7 years, maybe around approximate 10,000, all right, ringgit Malaysia. So dealing with the mathematics in big data, we cannot run away using a machine learning. Why? Because machine learning is artificial intelligence to provide the automatical learning and testing to predict something. All right. So you can see here, people always say that we want to solve using deep learning. Sometimes the data is not too huge. So they're looking, other alternative, for example, machine learning. All right. So the process we call is a artificial intelligence skill, all right, which is include into the data science. It's a part of the data science. All right. Okay. The next is what type of the machine learning algorithm that I want to focus. It depends on the company. If they want to do classification, we need to classify the data into two groups, or multi-classification into a number of groups. For example, data for the B40 range, above B40 and so on. All right. So the next is a regression. Why we need to do a regression? Because we want to do a forecasting. Forecasting. We want to find the risk. For the risk. For a specific business, for example. All right. And then of course to do a prediction. What happened? When we divide the data into the two group, for example, all right, clustering and then reinforcement learning. This is very important nowadays. People looking this type of the machine learning is a reinforcement learning. All right, gaming, for example, robot. One of the important indicator when we work with the industry. All right, so now the skill that we are mathematician, as statistician. So the expert, in the statistic, probability, for example, computer, coding, all right, and then deep skill on the programming, multi, languages, for example, Scilab, Keras, TensorFlow, and then R, maybe different platform, Linux, or Windows. So that is important for the industry because different industry, different languages. All right. So this is one of the skill that the companies need. For the mathematician. So you just improve one step. What is that? It's a programming, doing the coding. All right, because you have a good in mathematics, in the statistic, in the, all right, for example here, others in linear algebra, in the pure maths, in applied maths, and so on. All right, so now the next is as a mathematician, for data science and data analyst, we need to go through all this roadmap. All right, all this roadmap, mathematics, to get integrated with the statistic. To do the some prediction, forecast, stochastic, deterministic, all right? And then integrated with the programming, you have a skill on programming, and you start, to improve the prediction using machine learning, all right? And then towards the end, if the data is still huge, we are using deep learning, all right? And then with the specific algorithm and data visualization, because most of the stakeholder, manager, your boss, your CEO, COE, CEO, they're looking for the data visualization in 1D, 2D, or 3D. And then towards the end, the vision control, the software development. All right. So in mathematics, the skill for big data, they need a calculus, linear algebra, matrix operation. Very simple. permutation, combination. Okay, this is very simple. All right. So this business, okay, or the skill to be used in machine learning, okay, model. Okay. Now, for mathematics in machine learning, they're looking expert in the how you get a model from data. All right, do the primitive estimation, because dimensional reduction we need to do, because the data is messy, the data is too much, okay, factors and parameters. So how we make the parameter estimation and probability model and interference. All right, so this is one of the important graphical model, important because we want to visual the data in multi-dimensional angle. All right, so linear regression, dimensional reduction, okay, density estimation using Gaussian Maxwell model. I think this is an undergraduate student. They know, okay, degree, they know about the how to use the numerical solution, numerical analysis, okay, or sensitivity, some parameters about the convergence, about the stability. All right, so this indicator to investigate the performance of the method. All right, the statistic, I know, okay, as a statistician, we know what is the tendency, the measure of the data spread, the shape of the operation, the statistical application, okay, the statistical thinking, the mathematical thinking, logic thinking, all right, to do the transformation from the fundamental mathematics to the statistics theory. So this is I think, okay, based on the skill, okay, we can get a better, okay, better result, better world. All right, okay, because we can integrate, okay, okay, and then we can give a benefit to the customer, to the industry, to the organization, to the manufacturing, okay, because now they're looking at the alternative product during the COVID-19 pandemic. Okay, the other one is a programming. I know computer science, okay, student very familiar with the C++, now mathematics looking for the Python, R, MATLAB, Mathematica, because this is the object-oriented programming, which is easy to control and easy to visual, okay. Okay, for example, handling the matrix, okay, handling the data structure, okay, and then handling the syntax, okay, when we deal with the programming. Okay, data handling, okay, this is one of the, okay, also, okay, useful to be a data analyzer. What is that? Okay, how to do the clean data, how to do integration or ingestion data, how to collect the data, and how to do the data manipulation. All right, so this is one of the skill, okay, when we do the data handling. All right, so now I can visualize, okay, the disease in Malaysia, okay, the animal disease or agriculture disease in Malaysia. For example, okay, jaundice, okay, Nipah, brucellosis spread very drastic in Malaysia, especially in the north area, south area, okay, on the west and the east area. Why? Because we are using, okay, machine learning integrated with the GIS, Geo Information System, okay, to detect how the virus, okay, of the animal disease spread in the location of Malaysia. All right. So the other one is a machine learning. I know this one step, one skill. We need to know about the type of data, unstructured data. Just now I explaining. All right. And then structured data, labeled data, and labeled data. Okay. How to do the recommendation of the system. And based on the data, we can do many functions. For example, face recognition, all right, classification, all right, detection, okay, where is the location that you want to detect? For example, the images MRI, where is the location, the cell abnormal growth at the specific location? And then epilepsy, okay, how the beta, alpha, gamma, theta, and delta wave affected because of the epilepsy. So that is a detected. All right, segmentation, because the MRI, CT scan, okay, very huge. We want to segment the abnormal area of the tumor growth, for example. So that's important when we deal with the machine learning. All right. Why? Because again, machine learning, they can do the classification, clustering, regression, and dimensional reduction. Yeah. All right. So now, because of data increasing very fast, okay, the velocity increasing very fast every second, every minute, every time. All right. So data generate, okay, can be a big data, okay, maybe terabyte, gigabyte, yottabyte, okay, petabyte. So in this case, we start looking at the method to train and to learn the data. One of the method we call as a deep learning. All right. So in deep learning, okay, the basic one, okay, we can apply convolutional neural network, all right, or artificial neural network, the basic. All right. Towards the end, we can apply, okay, other neural network, for example, recurrent neural network. It's much more accurate for your prediction. So why we need to deal with the big data? Because when you compare with the machine learning, deep data can do data execution straightforward to get the performance of the result. We can analyze the result, all right? So no need to do the image processing, feature extraction, all right, pre-processing and so on. Because machine learning deal with the big data, they need to go through all the steps because the data is in very small, gigabyte, small byte, okay, of the data. All right, so now, okay, data visualization. Okay, I know there are many ways to do the data visualization. All right. Okay, for example, statistics, they also know how to do a data visualization. Mathematical modeling, they know how to do the data visualization using the model, like Dr. Jane, they're using mathematical modeling. All right. But in this case, this is a real-time visualization based on the increasing of the data, real-time simulation. All right. Why? Because we can, okay, describe the data, okay, understand the marketable of the product, for example. All right, we can do the art of the modeling, story, data, organization, and this depend on the creativity of the people we call as a mathematician or data analyst or data scientist. You see here. All right, how my student can visualize the data just now. Okay, you can see the data is a messy, kan? Many colors. Okay, multiple data set is an extremely large scale, dynamically heterogeneous of the data stream. But now we can arrange, okay, we can put the constellation chart of the data. For example, you can put in the graph of the nodes. We can link between the small data. We can categorize the data. We can put the classification of the data. Okay, the trustness of data, we can put in the 3D environment, all right? And then they put in the geography or the set of the polygon shape. You can see here, okay, where we can get a big data in the data constellation chart. Okay, this is important, how nowadays we can visualize the what we call multiple data set to the table of node, okay, table of link, constellation chart of the data, okay, what we call as a big data just now. All right, so people looking say that what is a big data actually? What is a big data? Okay, big data we get from the Grand Challenge application, all right, for example, sensors, all right, for example, okay, data that you generate, voice, for example, images, they can produce a big data, okay, nano computing, okay, and then, for example, okay, quantum computing also produce a big data, okay. Okay, and then this is a concept of the data engineering itself. And then to do this, we need to analyze the data using the, I'm using all the open source software, lah, all right, because it's very easy for me to handle the data. Okay, people said that what's different between big data and machine learning? Okay, you can see I explained in the 5 aspects. Data use for the foundation of the learning, okay, pattern recognition, data volume, and the how we propose the data. Okay, you can see here. Okay, okay, let's we go to the data use. Big data is a what we call is a set of data. Okay, they cannot function, okay, without machine learning. Machine learning is to train the data, one of the technology to drive the data, all right, and then to do the learning and testing the data, all right, so they can get the good prediction. All right, for the pattern, okay, big data, okay, they just give us a real sum pattern through the classification and sequence analysis. However, the machine learning, okay, they get one concept by using the same algorithm that big data analytic use to automatically learn and testing the data. So this is different, all right? So when we call, okay, why don't we integrate between the analysis, the big data using the machine learning? So this is our focus. Come on, when you say the data volume, machine learning using a small data, big data, they engage with the deep learning, all right? So this is the difference between the big data and machine learning, all right? So now, okay, because, okay, when we deal with the data, images, so on, we need to develop the software. I hope I can share with you, okay, the video how we create the software, okay, the software. Why we need to create the software? Because it's very important, okay, especially if you want to deal with the industry, stakeholder, hospital, and so on. All right. So you can see here. All right. I'm sharing you the system that we use to talk with the hospital, how we can categorize. Okay, we can classify the cell growth in the brain is a cancer or not cancer. So we are doing a post-processing. We are applying the machine learning, a few methods, okay, and we start comparing which method is better, and then we propose to the hospital whether this software is helpful. For example, when doctor have so many images, okay, for example, one patient, they have 36 images, they don't know, okay, looking from, because the data is a 2D, the images is a 2D, MRI images is 2D, so we try to convert in 3D, and we do the segmentation. One of the technique in machine learning we call as segmentation, train the data, and towards the end we can classify this cell is a cancerous or not cancerous. Okay, this is very important because, okay, when we have a software, okay, easy to deal with the stakeholders, with the hospital, and so on. All right. So now, what we are going to explain here, okay, we can visualize the data in the 3D. Okay, we have a data here, so many data, and then we do a performance evaluation in terms of the indicator, for example, sensitivity of the data, the specificity of the data, the precise of the data, all right? So the accuracy of the data. So we can visual in 3D. You can see, okay, green color is a tumorous, red colors is non-tumorous. So if the images come to this machine, okay, we can classify the data where the green color tumors, okay, not normal data, or red color is a tumorous, right? Based on the specific approximation, okay, parameters, weighted parameters, all right? So this is
Dr. Norma, we still have about 10 minutes.
all right, so now, okay, when you deal with the big data, what is a tool? Okay, how to simulate the big data? So I'm suggest you, okay, a few tools. Okay, this is a question from my student. They said that what is a big data? How to analyze the data? How to do a simulation of the data? All right. So how to get the data? This is a common question. Okay, when we pose the Padlet to the student, this is a question. So my answer is, okay, we are open to the software, okay, software to analyze data. I'm using MPI, okay, CUDA, for example, C++, Linda, to do the multi-dimensional of data visualization. All right. So to do this, okay, I need a huge computer, which is high-speed processor and huge memory architecture. All right. So this is the software to deal with the machine learning and deep learning. Okay, people, you can see here, people always know about the SPSS, okay, Spark, Hadoop, R, for example, okay, you are very familiar with the Tableau, Quick View, okay, NumPy, SQL Server. This is very good because this used to arrange the data. For data scientists, okay, again, okay, we are using R, we are using IBM Predictive. All right, we are also using SAS for statistics, okay, to get the important specific data or the what we call is a pioneer data, all right, the structured data, for example, and then the keras. And then the one is a open source, approximate to keras is a Scilab, okay, TensorFlow, all right, and then Jupyter, all right, and so on. So how to analyze a big data? I'm using high performance computing. Nowadays, I'm using GPU, CPU, all right? So last time I merged a number of computer, what we call as a distributed paracomputer system. Another skill, okay, we need to know is converting from sequential that you're doing now to the parallel architecture. So in the Fugaku, okay, architecture, they said that they are very good, okay, providing a cloud to simulate the coronavirus treatment, okay, for the specific problem, okay, because they have 415 quadrillion computations. Okay, this is a machine that they are very proud. This is the latest one, very huge, okay, to solve a problem. So now, what is our challenge? Okay, we are mathematicians. So what is our challenge? Our challenge now is a multidisciplinary. Data comes multidisciplinary from every angle. Okay, they request us, okay, to deal with the statistic, pattern recognition, okay, database, okay, bank of data, data mining, artificial intelligence. All right, so this cycle will create, okay, the problem. We solve the problem using the artificial intelligence, okay, with a strong mathematical modeling, with a strong statistical approach, and then we can do a business analysis and business strategy to develop a new business model. All right, so this is a challenge people dealing with the mathematics and the big data nowadays. All right, so we hope that, okay, you can build, okay, build a skill. Now we are in COVID-19, we develop a skill, okay, develop the connection between the industry, between the subject matter with the project, okay, between the, okay, maybe shareholder, okay, or people, okay, for your mentor, all right, expert in the machine learning, all right, or data scientist, or data science, or data analyst, all right. So this is a will integrate, okay, the knowledge, okay, fulfill requirement for 2021. All right. So now, other skill is okay, I already explained just now. What is a classification, dimensional reduction, feature extraction, pre-processing, and processing. All right. So what is our future? Okay. Okay, we have a very good future. You know why? For 2022, there is a 2.3 million job opportunity for mathematician and statistician. All right. So how many? 2.3 million job opportunities for them, and then will grow up to 42.2% to reach US$ 9 billion for 2020. So you have a good spec now. All right. Why? Because, okay, as a mathematician, as a statistician, you will always deal with the algorithm, you will always deal with the modeling, you always deal with the simulation, and then now people looking for the quantum computing based on the unsupervised data algorithm. All right. So all the powerful robot now, okay, for industrial 4.0, right, dealing with the internet of things, dealing with the smart city, smart school, okay, smart device, and so on. So they generate, okay, every second data, and then we need to analyze the data, and then towards the end there is a potential customer online behavior monitoring. All right. So how the machine learning give a good solution, a good monitoring, a good observation, and good prediction. All right. Up to what extent? To the visual recognition, to the speech, to the sound, to the voice, for any types of data that we can analyze. Okay, so to that extent nowadays. All right. So you can see around you now. How many devices around you? 4 devices. I know your washable, wash, okay, wash, and then the handphone, the device, iPad, okay, especially people dealing with the educator 4.0, there are many devices. So we generate a data every frequently, all right, every second, all right. So now you can see, okay, people for 2025, there is 25 billion devices in the world, all right. So how we create the data. So I can't okay, explain so much. Okay, now people looking for the device, talk to device, IP to IP, cloud to cloud, and then system to system. Now this is a we call as a third layer communication, right? The important is for mathematician and statistician, we need the honest data. We need the data, trustness data, which is easy for us to analyze the data. We need fully trust and quality data, okay, to get an accurate solution, all right? So this is what we want, all right? So I don't want to go for the challenge, okay, because I know the challenge now is a complexity or multidisciplinary database, all right? So as a mathematician, I love to put in the red, okay, circle here. You are dealing with the data, meaning that mathematician in big data, they can do a better prediction, a better decision making, all right? So before I last this session, I just want to address there are 3 philosophy, mathematician and statistician in the big data. What is that? The first is a literacy, how you engage with the data, how you do the communicate with the data, how you analyze the data. The second is a competent, how you use the hardware, software, all right, the application, the network, okay, the device, okay, to deal with the data. And then the last is a ethical crossover, all right, how the responsibility to develop a good okay, prediction, the functionality of the ethical, all right, and then the holistic value for the humanizing, okay, mathematics in big data, all right. So I hope, okay, all the intellectual aspect, for example, the spiritual, the heart, the soul, okay, the thing, okay, the brain, okay, will develop a good knowledge, okay, more wisdom, and it depends on you to choose the intellectual element, okay, that you are going to address. Okay, as a conclusion, okay, I just okay address here. Okay, as a mathematician, statistician, for the better world, for the better decision making, for the better prediction, okay, we are dealing with the theory. After dealing with the theory, we know how to operate this theory can be tested empirically using the qualitative data. This is very important. Dealing with the theory, mathematical modeling, and the data itself. All right. So what we can deal, we deal with the 3 philosophy. All right. What is that? Literacy, competent, and moral, okay, and the integrity, all right. The innovative technology able factors to become a smart result. Smart result means that very good prediction, very good forecast, very good projectors, okay, by integrating data, all right, cloud, robot, because nowadays all we are using a wearable, okay, a wearable device, internet of things, all right, and then high performance computing or the server to solve the big data simulation, all right. So we hope that okay, the data driven will develop decision making for the multidisciplinary skill that I presented before, all right, dealing with the job career for the mathematician and statistician as a data scientist and data analytics. Okay, so I think I send back the session to the moderator, okay, Dr. Sze San Nah. All right.
Thank you very much, Dr. Norma. This is a very interesting talk. I think you open up the mind of all the students here who study mathematics that actually the career is there, the demand is there. So 2.3 million of job opportunity. There are 50 behind the 3. So you can imagine how important the mathematics that lead you to analyze the data to become the data scientist and data analysis. And also, I think this talk is a very good for those students that looking for idea for your final year project, because the application is everywhere. Okay, so now let us begin with the Q&A session. If you have more questions to Dr. Norma, you can put it into the Q&A window. Okay, the first question here. I think this is addressed to Dr. Jan. A student asked, I guess she's a student, I would like to try the SEIR model, model on the stock market later on, because the prediction of COVID is highly matches. Is that possible for us to apply the model for the stock market predictions?
Well, I'm not too sure because that hasn't been done before. Because as you know, the SEIR, it is looking at the population. It's to do with the human population. However, one thing that you need to do first, you can find out the relationship or just do a correlation between the number of cases and the stock market. So if there is a correlation, then there must be some way of putting this together. Okay, a relationship between the number of cases and also how the stock change as time progresses. So you can actually do that and come up with a model, a regression model, as what is mentioned by Dr. Norma just now. But to use specifically the SEIR, I'm not sure because we are talking about human there. But if you want to include some parameters to reflect on the stock exchange, it's a bit of thinking that needs to be done on that. There are actually mathematical models that is using differential equation on stock market. That is the Black-Scholes model. So you can look it up, Black-Scholes model. Yeah. So look it up and how they use that. So it is not really SEIR. They are using differential equation, but they use something to do with a fluid dynamics theory behind it. Okay. Black-Scholes. Okay, I'll write it down later in the Q&A.
Okay, thank you very much. The second question is, if a student want to start to study on the disease modeling, and she believes that she might need to get permissions to get some data from government agency. So if she cannot get the permission to get the data, can she proceed with that, and how to do so?
Okay, good question. Data is needed for this type of problem. So if you require only the number of cases, active cases, and this is available publicly, therefore there's no harm because they already put it up as publicly available data. However, of course, ethically, you will need to acknowledge where you get the data from. Okay, so so for that type of data, that is okay. For data that is perhaps not available in the public, so in press statement or whatever, then yes, you may need to get permission. You need to get someone in the Ministry of Health to work with you, to collaborate. So there must be some sort of understanding between you as the modeler as well as the ministry, okay, the data provider. So yes, you do need permission. But for data that is available publicly, you can use it as you want, but acknowledge it accordingly. I hope I answer you.
Okay, next question. I believe this question is addressed to Dr. Norma. How should we explain to people if they think the company do not have a huge data? So they think they do not need a data scientist or data analysis.
During the COVID-19 pandemic, okay, most of the business cannot work, all right, closed because of the distancing and then because of the regulation from the government, from the world for now. So now you can see most of the industry, most of the manufacturing company and organization, they start looking their previous data. All right. For example, Asia, Shimano, all right, and then nowadays Petronas, they're looking from the previous data. Okay, most of them they are looking from the customer, the data from customer. That's why the monitoring customer is very important. So, okay, for example, Asia, they're looking, okay, from the customer, they're looking for the food, for example, okay, cosmetic, for example, the beauty, okay, the healthcare, okay, business, and then they're looking at the town, okay, the land, they start do the agriculture, right? So why? Because they're people, okay, looking for the data, they analyze the data. All right, my student are working in the Asia, okay, they are now writing the report based on the data and then data cleaning for their dashboard, okay, for their data scientists, okay, and then towards the end they analyze. Okay, so I think okay, it depends on the company. If the company is too big, I think they're dealing with the big data because they are generate the data a few years. Okay, but if the new company, a small company, the data is very small, so we are looking, okay, to analyze the data using machine learning. Right? For the big data, we are using deep learning. All right. So okay, this is one of the action nowadays. People doing a data analysis. Okay, data science. Okay, and then because they can do the decision making. What is the business model during the COVID-19? What is the business model after new norm COVID-19? All right. So this is one of the important aspect. Even though in Malaysia need 20,000 okay data analysts and data scientists. All right. And then the salary is much more higher than engineers.
And a lecturer.
And lecturer. Yes. My PhD student, okay, working with the investment company, international investment company, and then the salary is much more higher than lecturers. Yes, I agree.
Yeah, I also get the same information from my alumni students actually. Dr. Norma, would you please share with us that how we would like to know how your experience as well inquiring the data, the trust data, the honest data for your problem domain?
Okay, the trustness data is from images, MRI, mammogram, CT scan, geo information system. All right, and then EOG, EEG, all right, the wave agrography, and then the nano camera, what we call FEM, SEM, because they will create a real data, real time trustness data. We just convert from the signal to the digital data using MATLAB. Okay, don't worry, we can use MATLAB. And then based on the digital, okay, we start do the pre-processing, feature extraction, okay, and then classification or segmentation. Okay, if the images we want to specific area, we go to the specific segmentation. So that is a trustness. And then when we compare with the mathematical modeling, because my previous expertise is in mathematical modeling. Okay, we are mathematician. We deal with the ODE, PDE, and so on. All right, many types of the modeling. All right, Dr. Jane using SIR model. So we can compare the real-time solution based on the data-oriented and then the mathematical modeling. All right. Yes, the mathematical modeling can predict what happened to the future of data. All right, but we need to input, okay, some controllability parameters. Okay, for example, Dr. Jin using mass, kappa, whatever parameters to control the model. So, however, the data generated from device, from sensors, from meters, and so on, they are really trust visible. Okay, and then velocity, and then variables of data. So we can choose which is important for us to do a decision making. So now, actually I already move using a trustness data to confirm my mathematical modeling is correctness. Right?
Yes, thank you. The explanation is clear. Okay, one last question. I think this question should be from me to Dr. Norma, Alias. Do you think there's a market for mathematical program offered maybe at the postgraduate level?
Okay. All right. I know you are a mathematician, you are statistical, you are very good in mathematics, you are very good in statistics. I know. But now if you want to market yourself, all right, market yourself, you need to other skill. For example, is a coding, all right, programming. And then the programming you need also know about not just MATLAB, Mathematica, Maple, no. Open source software, for example, R, Python, Scilab, TensorFlow, all right, Keras, because in the company, they are no source, they have no license, to analyze the data. So when you have a skill, all right, because based on my experience, my undergraduate experience, they are undergraduate only, and then they are also postgraduate, they have no job, full, now lecturers is full, all right, so they go for the company, and then they are I can market my student. Marketable, employability is very high because they have a skill. What is their skill? Not just a mathematician and mathematics and statistics, but they have the programming. They have numerical modeling. They have know how to use machine learning, support vector machine, artificial neural network. All right, they compare basic of the deep learning and machine learning method, all right? And then towards the end, they know how to predict, they know how to visual the data. The data is, just now you said messy, hyper, homo, or heterogeneous data. So the stream data is heterogeneous, but you know how to visualize in the 1D, 2D, or 3D visualization of the data, and then make the people, make their boss, make their CEO or stakeholder, their customer happy because they can find what happened to the company after 2 years, 3 years, if we are still in the new norm COVID-19 pandemic. All right. So Alhamdulillah, all my students, are market already. No, none of them jobless. Unless they are housewife. They not go to job. They not go to work because the husband not allowed. So that one is a special case. But until now, just now, I have 2 undergraduate students. I have 3 postgraduate students, all working. Alhamdulillah. So I'm very happy this line, but you need to increase yourself in high performance computing because you deal with the big data. You cannot work with the one CPU, one laptop, one processor, all right, one device. You need to integrate a number of processor, a number of device to develop huge memory, huge memory architecture and high speed processor to solve a large task simulation.
So to our students, as a conclusion, you have the mathematics knowledge. So you need the enable programming skill, then you become the hot stuff. Okay, so as we have exceeded the time already, I think we have to end the sessions. If you have further these questions, you can always contact any of our speakers through their email. You can easily get the email from Uncle Google, so don't worry about that. Now, let us make a big noise by switching your mic and turn on your video. Can you all turn on the video?
On.
Hello. Hey. Ow.
Yes. Big round of applause for our panelists and to all of us here.
Great talk. Thank you.
Indeed, an introduction and
I see.
right. Thank you. Okay, thank you again. Okay, can you hear me? Okay. Okay, thank you again to the panelists and everyone here. Let us wrap up the sessions with a quote by a famous Russian mathematician, Nikola Ivanovich Lovacharsky. I hope I pronounced his name correctly. There's no branch of mathematics, however abstract, which may not someday be applied to phenomena of the real world. And I'm sure we shall use mathematics for a better world. Till next year, stay safe, everyone. Bye.
Bye. Thank you. Thank you, everyone.
Bye.
Bye.